keywords.name/packer. All you got to do is paste in your JavaScript, and it will create a fantastically obfuscated form back for you. There's another one called Script Asylum Encoder and Decoder. When you pack your JavaScript in this manner, what happens is you get this big packed and encrypted, encoded JavaScript. It will decrypt in memory and then render your exploit. And this is enough to fool most antivirus programs. Let's see how Teflon fares against both of these. So, here. Here's the packed version. So the same simple JavaScript code now got transformed into all this. You have this hideous JavaScript that's impossible to read, but it's like eval and blah blah blah. All your variables are broken up into tokens, and your data is over here somewhere. But basically, what happens at the end of this, you will have your original code constructed back, and that will run and own you. So let's run this. Okay. Now, let's run this without Teflon and see how it works. Reload this. There you go. It blew up. It decoded itself and then rendered the exploit, blows up. And now let's see how it fares with Teflon. It's obviously not going to work, because otherwise I won't be standing up on stage doing a demo. Okay, now let's do this. Restart the web server. And sorry? Oh yeah. Finger error. There. Thank you. There we go. Now you can see in the Teflon messages, first what happened is the big unpack happened, and you have your original JavaScript being decoded after being unpacked, and then Teflon kicks in. So you have one more iteration, but that's okay. Let me show you a rendered source, view formatted source. So this was the original JavaScript, which was all heavily packed and obfuscated. Once this ran, it unpacked my original exploit script, and then we have Teflon kicking in after the second unpack. So normal stuff runs, but malicious stuff gets stopped. Let's try another instance. Let's try the Script Asylum Encoder and Decoder version. So here is the encoded shellcode with Script Asylum. This makes it even worse. I mean, you have document.write, unescape, everything's all this gobbledygook stuff. And to make matters more interesting, we say we'll do both. We'll do packing and encoding, like double layer obfuscation. So FF both is both packed and encoded. So first it will get decoded, then it will get unpacked, and then the exploit will try and render itself. I mean, this is impossible for any AV or any IDS. IDSs are a joke, by the way. In all honesty, you have an IDS, it will be nothing but Das Blinken lights. Nobody really cares. Every pen test that I've done, there's always this one pen test that you do every year where you bust everything and dance. Some company always gets one like that. They'll have it all. They'll have firewall and IDS, and well, yeah, guess what? My big port scans showed up on your IDS, but nobody did it. Anyway, end of rant on IDS. So let's run this, and both doubly encoded and encrypted stuff. let me just close Firefox so it will purge the cache and everything. And now, so let me turn on the error console there. Let's also turn on Teflon. And now, there it is, load it up. Now you see multiple iterations. So the first loop ran, it got decoded. It got decoded into the packer script, then it got unpacked into my original exploit. And then Teflon kicks in at this point. So let me show you the rendered source for this. So there you are, the original stuff, that's all over here, both packed and encoded. It got decoded and resulted into this packed script. It got unpacked and resulted into this stuff. And then, so there's like the DOM mutated thrice, and the fourth time I intercepted it and stopped. So that's what it is. That's what Teflon does. Let me show. I tested this out in the wild as well. I just pointed it at some various malware sites. There's one particularly interesting stuff that I found, which I copied. So here I showed you how Teflon fares against both of these. In the wild, I came across a site like www.qqq.cn. This will deliver you the latest malware whenever you browse to it. I mean, this is like big ass malware delivery engine. This gives you various iframes and 3 or 4 most current browser exploits. If you haven't patched it, or you have some vulnerable versions of toolbars or plugins going in, a visitor is going to get owned. And by the way, if you want like cool 0 days, go to this site and just grab the code coming in. Of course, be careful. Do it from a VM, which you can undo later on, but it's a nice source of picking up new stuff. And this was fantastically encrypted and randomized. I was amazed as the kind of work that is going in. I mean, without all it is the simple IE vector markup language bug, which came up last year, but it's delivered in this wonderful encrypted and randomized way. And without Teflon, you'd get owned, but with Teflon, it works. Let me just show you instead of screenshots. So here it is, MS 07004. I mean, here's the code. If you reload it, you'll get different variable names every time, and all this stuff is encrypted or obfuscated. And then down below, you have all these various bit transformation functions of MD5 and bit to hex and whatnot. A whole lot of S boxes type of stuff. And here's the best part. Every time you load it, you get a new variable over here. You get a pass is equal to something else, and this will be used to decrypt all that encrypted shit. Every time it's something different, so you really won't be able to build up any signatures against this. And lastly, when this code does perform page, that's it. That's when the exploit triggers. Until you get to the last piece of the puzzle, you won't have any signaturable exploit in this guy. Let's run this. Let's load this up in the browser and see how Teflon fares against it. So here we are, and let me shut this down and clear the cache. Turn on Teflon, error console. Okay, so there we are, loaded up. It's blocked. We don't get a shell. Anyway, it's an IE exploit, so it won't work in Firefox anyway. But got intercepted and blocked it. And here's here's what Teflon detected. So once all that decryption happened, here's you can see class ID is equal to 100 something. It's referring to the IEVML object. Then you have all the shellcode over here, and then down here you have the body on load is equal to whatever, and draw your vector markup language tags and blow it up. If you look at the rendered source, I mean, the whole thing expands. This is the original stuff. The original stuff that got delivered with all the decryptor stuff built in. And then when it ran, it got decrypted into this. This is the decrypted exploit code. So shell is equal to one escape, and then you have all your heap spray stuff going on over here. So here's the heap spray code. There's actually the same stuff lifted from Skyline's code. And then here you have all the HTML tags VML tags which will render you that malicious VML tag and blow things up. So this is what the state of exploits is today, and that's what I hope to stop with tools like Teflon. So with Teflon, all we get is a harmless div tag. So to put some closing thoughts to the work that I've done, in Teflon, I'll admit it's not super perfect. It's something that I cooked it up. It's still version 0.2. It's not a very usable version. I mean, who the hell uses version 0.2 code anyway? But the whole world does with a damn thing called Google Chrome, I tell you that. So buggiest bloody browser in the world, but half the world's using it. Why? Because it got launched with a comic book from Google. Anyway, you can see I'm a pretty bitter guy when it comes to browsers. I don't spare any browser. But the thing to think about with Teflon is, right now what I'm working on is how can we make such technology built into the browser? How can we make this work in practice? How would this happen? Maybe maybe with Teflon you have a list of known malicious objects, something like Microsoft Killbit stuff. You just load it with known vulnerable COM objects or vulnerable ActiveX stuff or vulnerable object tags, and block these at the get-go whenever you see them. So existing vulnerabilities may be tackled. If you may also program things like you don't want to see object parameters more than a certain amount of bytes in length, and this may very well just blindly stop some basic buffer overflows that may come up in the future. Or you may have some fancy implementations like a website. When you load up a website, the web server headers will send a list of what is allowed on the website and what is denied. Something like, say, if you go to youtube.com, YouTube will send a header back saying the only object tags allowed on youtube.com are flash objects. So if you have any other object through some malicious iframe or something else, if you have anything else being rendered through the YouTube site, don't run it. And a tool like Teflon can obey these tags and enforce those policies for that website. There's a guy in Mozilla, Brendan Stern. I'm working with him right now. He's building a project called the Site Security Project that is mainly for the cross-site scripting and cross-site request forgery stuff, what I call user-land stuff. And he's developing a framework on how do sites declare what is allowed and what is denied. And something like Teflon can work very well with a site security project plugin, is that in addition to what JavaScript sources are allowed, the server will also transmit back tags saying what tags are allowed and what tags are denied. What I want to underscore is there's got to be some mechanism, some standard mechanism built into browsers using which websites or even users can control what tags can be rendered and what tags are to be denied. Some sort of syscall marshalling for browsers. So I don't know how this will work. I mean, there was something done similar. There was the whole P3P project, which sent a whole lot of privacy tags, but